All right, guys, this is our video on the review for the algebraic reasoning topic for the TSI test. Okay, so this first one, we're going to solve for k, and this is called an exponential equation. How we did this in the first semester was we're going to rewrite 16 using a base of 4. So let me copy the problem for you. All right, so let's rewrite 16 using a base of 4. That would actually be 4 squared. Copy down 2k minus 6, copy the right side. And then remember we did this in the first semester. This 2 that you put in there to be 4 squared is going to distribute onto both the 2k and the minus 6. So it's going to be 4 raised to the 4k minus 12 power. Once you do that, you should see that the bases are the same. So essentially, I'm going to just set the exponents equal to each other and solve. So moving this 2k over with subtraction. Sorry. So 2k minus 12 equals 0. Let's move the minus 12 to the other side to get positive 12. So k is equal to 6. So the answer is A. All right, that's how you do those solving exponential equations by rewriting the bases to be the same. Number 2, which of the following inequalities describes the situation given below? So number n is multiplied by 2, then 12 is subtracted from the result. So this doesn't have n being multiplied by 2. All right, and then in terms of this one, it does multiply by 2, but if you were to distribute this 2, you would actually end up then subtracting that result by 24. So the answer is going to be D. That final result is less than 40. Number 3, what are the x-intercepts to this function? So first you want to set it equal to 0 if you're finding x-intercepts, right? Because that means that you're on the x-axis, so your y value is equal to 0. And g of x is just a fancy way of saying y. So I'm going to factor this by grouping because I can't factor out any common factors. So when I factor out x squared out of that first group, I get 3x plus 1. When I factor out a minus 4 of the second group, I get 3x plus 1 as well. And remember, this has to be true, right? These have to be the same when you're doing this if you're going to continue with factor by grouping. All right, so then you're going to take the stuff that you pulled out, the x squared minus 4, and that's going to make a factor. And since they share the 3x plus 1, that's a common factor, just bring down one of those. This is the difference of two squares. X squared minus 4 is called dots, or the difference of two squares. So I'm going to factor that as x minus 2, x plus 2, bring down the 3x plus 1. So the answers here that would make each of these 0 are 2, negative 2, and negative 1/3. So in terms of finding my answer, these don't have all three answers. So the one that I'm going to choose is A for those 3 x-intercepts. Okay, number 4, Lauren deposits $30,000 at a bank with a 7% interest rate. After a certain number of years, the compound interest is that value. Find the value of x. So we actually used this formula recently. So our final amount is actually going to be 36,751.29 because you're adding how much Lauren deposited and then how much interest she earned. The original starting amount is that lowercase a. The rate is 7%, and we're solving for t or x, the number of years. All right, so you have your answer choices here. If you wanted to use your calculator to type in t and figure out which one matches, you could do that. I'm going to solve this a long way using logarithms. So the first thing I'm going to do is divide both sides by that 30,000. And you could go ahead and get a value if you wanted to, or you could leave it like that. I'll go ahead and show you the calculation of 36,751.29, so 36,751.29 divided by 30,000. So approximately 1.225. Again, I'm going to put approximations on my work, but when I use my calculator, I'm not going to round. So this is 1.225 equals, if I put that together, we get 1.07 to the t power. And if you remember what we did in the first semester, to get that t out of the exponent, I'm going to take the log of both sides. So I'm going to put log in front of both of these. So now I have log of 1.225 equals t times the log of 1.07. So to get my t, or x in number of years, I'm going to divide that log of 1.225 divided by, the log of 1.07. So if I write that in the calculator, I will get my answer. Again, I'm not going to use the rounded value. All right, I'm going to type log of 1.225043 over the log of 1.07. So it gives me an answer of 3 years. X or t is 3 years, so D. All right. Again, I know that was a long way and probably more complicated with logarithms, but I do want to remind you that you did learn how to solve exponential equations using logarithms. Okay, number 5. How many solutions does this quadratic function have? This is actually a question from your days in Algebra 2, talking about something called the discriminant. The discriminant, which is b squared minus 4ac, you probably recognize that from part of the quadratic formula. The discriminant, the sign of that, sign, will help you determine the type and number of solutions of a quadratic. So if this a is 1, b is -7, and c is 2, and I plug that in, I get -7 squared minus 4 times 1 times 2. So that's 49 minus 8, which is 41. And I don't care that it's 41. What I do care is that it is a positive, so I'm going to have 2 real solutions. If your discriminant was negative, you would have 2 imaginary or complex solutions. If your discriminant was 0, you would have 1 real solution. All right, so that's how it works. All right, number 6. What is the domain of this function? So this is called a square root function. So I'm hoping that you'll know how we graph this. Let me first just set this equal to 0 so I can find an x-intercept for you. So if I square both sides, you get 0 equals 2x minus 5. Move the minus 5 over, and you get x equals 5/2 or 2.5. So this is my x-intercept. Now, to graph it, if I were to go to the left of 2.5, I would plug in 2. If I plug in 2 where it says x, I would get 4 minus 5, which is -1, and the square root of a negative is not a real number. So actually, to make this, we make like half a parabola on its side. And because you can take the square root of 0, when I choose my domain here, I'm looking for values that are equal to, but also greater than 2.5. So greater than or equal to 5/2 is what I'm looking for this answer for the domain. All right, let's keep going. Number 7. Which of the following is or are correct solutions to this radical equation or square root equation? So I'm going to move that 5 over with subtraction first. Okay, and then I want to get rid of that square root. So I'm going to square both sides. When I do that, when I expand this z minus 5 raised to the second power, you could, if you wanted to, write z minus 5 twice and multiply it all out. I'm trying to teach you to take the first term, square it, take the second term, and square it. And the middle term is the first term times the second term times 2. So that's going to be -10z. Okay, when you square a square root, the radical will come off and give you 12z plus 4. Let's get everything equal to 0. So I have z squared. When I move over that 12z with subtraction, I get -10z minus 12z, which is -22z. And when I move the 4 over with subtraction, I get 25 minus 4, which is 21. So if I factor this quadratic trinomial, I get z and z. 21 and 1, and my signs are both going to be negative, because a negative 21 times a negative 1 is positive 21, and a negative 21 plus a negative 1 is negative 22. So my answers are 21 and 1. Now, don't just put D as the answer. When you do this, you do need to check for what we call extraneous solutions. So those are answers that you got with your work, but when you plug it back in, it's not going to make any sense. So if I try 21, so 12 times 21 plus 4, and then plus 5. 12 times 21, 12 times 21, let's do a square root of that. 12 times 21 plus 4 is 16, and then 16 plus 5 is 21, so that works. But when I check the next one, plugging in 1, I get 12 times 1 plus 4 plus 5. 12 times 1 is 12. 12 plus 4 is 16. The square root of 16 is 4. 4 plus 5 is 9. That's not equal to 1. So the only answer that's going to work here is positive 21s, because when I plugged in 1, I did not get a true statement. So the answer or solution 1 that we found is called an extraneous solution. All right, let's do 8. All right, so we've got some coordinates here of 1, negative 3. So this is point J. And then point K is 6, negative 2. And we're trying to find the distance of the line segment JK. Hope they did it on purpose. Now, you could, if you wanted to, I know when you guys were in geometry, you probably memorized the distance formula, but I choose to teach this as making like a triangle. And if you were to make a triangle from this, and more specifically a right triangle, you can use your understanding of the Pythagorean theorem to solve for this distance, right? This hypotenuse, which essentially, if you don't know, is how they derive the distance formula. So let's first find this distance from left to right. You can call whatever letter you want. I'll call it x because I'm moving in the x direction. So that's going from a distance of 1 to 6, which is 5. And if I do my y value is in blue, going from negative 3 to negative 2, that's just a distance of 1. So to find my distance in JK, so to find this line segment distance, I'm going to do 5 squared. I should say this distance squared is equal to 5 squared plus 1 squared. So that distance squared is 25 plus 1, which is 26. Again, I don't want JK squared. Right? I don't want JK squared. I want just JK. So I need to take the square root of 26 to get the distance from J to K. So that answer is D. All right. Number 9. Number 9 is subtracting two rational expressions, and you need a common denominator. So let me copy it down over here for you. Now, the thing about this is that you actually don't have anything in common if you treat this as if they were two different factors. So we need to multiply by the other factor, top and bottom. So x plus 4 over x plus 4 over there. And over here, we're going to multiply x minus 2 over x minus 2. That would give me a common denominator of x plus 4 times x minus 2. Now, when I distribute the numerators, I get x times 7, which is 7x, 4 times 7, which is 28. Now, it's up to your preference or how your teacher taught this. I choose to think of this negative distributing with the 3. So I write negative 3 times x, which is negative 3x, and negative 3 times negative 2, which is positive 6. I usually get more success, or less students are going to make mistakes if I do it that way, but it's up to you on how you want to do it. So 7x minus 3x is 4x. 28 plus 6 is 34. And if you look at this, you're looking for the only one that has 4x plus 34 in the numerator is going to be C. And if you're wondering how they found that denominator, they distributed the two factors in the denominator to get that. All right, so 9 is C. Number 10. Number 10 is a rational expression of just one of them. And when you simplify them, all you're going to be doing is factoring to get as simplified as possible. So that numerator, I'm looking for factors of -6 that add to 1. So that's going to be 3 and -2. In the denominator, I'm going to first factor out an x to leave me with x squared minus 3x minus 18. I'm going to copy down the numerator, bring down that x, and now let's factor factors of -18 that add to -3. So let's use 6 and 3. Let's get the signs to work. So -6 and plus 3 should work. All right, and then cross out anything that's in common. And you have x plus 3 in common. So the remaining stuff will be your answer, which is x minus 2 over x times x minus 6, which they have just distributed to get x squared minus 6x. So the answer is D. Number 11, what is the range of this function? Now this, I put this on the review because it may have been a while since we've done this. It has. But if you look in this, it's an exponential function because you have x in the exponent. And then you have 1/2 in the parentheses, which you could rewrite that as 0.5. Because that base is between 0 and 1, this is an example of exponential decay. So when you graph it, right, the way it works is this -2 is going to be a horizontal asymptote at y equals -2. And to make your graph, you're going to draw a curve like this. I'm going to probably get the y-intercept messed up, but it's just a sketch. But the idea is that in terms of your y values, you can go all the way up to infinity, but you're not going to get below -2. So when I ask for the range, which are y values, I'm looking for y values that are greater than -2. Notice cannot be equal to because we're never going to touch -2. That's 11. Let's do 12. So this one says, which of the following is an asymptote? There are actually two types of asymptote. There's horizontal asymptotes and vertical asymptotes. And this one, because all of your answer choices say x equals a value, these are talking about vertical asymptotes, which would make this denominator become 0. All right, so is there a way to make x minus 1 squared become 0? And there is. If you take the square root of both sides, you get x minus 1 equals 0. So x equals +1. So the answer they want here is D. But technically there is another asymptote. This -4 out here would be our horizontal asymptote of y equals -4. All right. Number 13, which relation is not a function? Remember, to be a function, you cannot repeat x values with different y values. So when I look at this, it's repeating y values. That is okay. That is totally fine. That is a function. This next one doesn't repeat anything, so that one's fine. We actually call that a one-to-one function. And letter C is the issue. You'll notice we have 2 and 2. If you make a little sketch here, 2, -1, 2, +1. This is an example of it failing the vertical line test. So you cannot repeat x values if you're going to have different y values. You'll see that these y values are different. So C is the relation that is not a function. 14. Let's simplify. What I try to do first is I try to get everything that has a negative exponent. I move it across the fraction bar. This one might be the trickiest part of it. So if I highlight that, right? When you hopefully remember when you do a power to a power, you get s to the -4th power. So I'm going to rewrite that as s to the +4th power up there. This r to the -2nd power to move down to the bottom. There's already an r cubed down there, and that s to the -1st power is going to come up top to be s to the +1st power. So then I simplify in the numerator and get r to the 4th power times s. This is going to be 1 plus 4 plus 1, which is going to be 6. And in the bottom, that's going to be 2 plus 3, which is 5. So we already know s to the 6th power is going to be on top, so that can tell you your answer. What I tell students for the r's is which one has more. the denominator by how many? 1. So it's going to be s to the 6th power over r to the 1st power, which is a. All right, last one, and then we'll be finished. What is the minimum for this quadratic function? This is actually asking you to find the vertex. The vertex of a quadratic function will always be where you find your maximum or your minimum. The reason this one is a minimum is because, I'm sure I'm going to get the sketch wrong, but the idea is that when you have a parabola opening up, your vertex will be the minimum value. If your parabola was opening down, then your vertex would be the maximum. So the formula you guys use in Algebra 2 is x equals the opposite of b over 2a. So a is 3, b is 6, c is negative 10. So the opposite of b over 2a, I teach students, and this could be different than your Algebra 2 teacher, I teach students to just do the opposite of b right away. So the opposite of 6 is negative 6 over 2 times 3. So that's negative 6 over positive 6, which is negative 1. Now that's not the answer, right? That is where the vertex x value is. To find the y value, you plug it into the original function. So 3 times negative 1 squared plus 6 times negative 1 minus 10. So negative 1 squared is 1, so that's 3 minus 6 minus 10. If you add that or subtract that left to right, you get 3 minus 6, which is negative 3. Negative 3 and a negative 10 is negative 13. So our y value is negative 13. That is the minimum value for this quadratic function. All right, so good luck. Make sure come see me if you have any questions, and I hope you do well on the post test.